talked about graphing sine and cosine. So here's a lovely sine graph. We talked about for sine, if you change your amplitude, right? If you increase your amplitude, it got bigger. Hold on, let me slid over here. Okay, so we talked about when you increase your amplitude, then it gets bigger, like the waves will get higher. If you increase your period, right, the period got smaller actually. So like if you had a b value that was next to your x, you could kind of squish it down this way. So we talked about sine for that. We also talked about cosine, which is also a pretty wave. Cosine looks like that, right? And again, the amplitude changing and the period changing, what does that do? So that's what we did yesterday. Today is bizarre because we are going to talk about tangent, which is not a pretty wave. Tangent looks like, why do I have a C there? Hold on, tangent, there we go, yeah. Looks like that. So if we're talking about tangent, this is one period of tangent shown. Technically, it's just like that half of the graph or that half of the graph. So really, this is two, because the negatives are positive. And then what does the amplitude do? Because now we don't have amplitude, but we do still have an a value. So what that's going to do to our tangent function and so on. Because yeah, tangent looks pretty weird, huh? So if you can go to underneath your example 2 on yesterday's notes, where we have this big blank space, I made 2 mistakes on your notes, because of course I did. Your worksheet's fine though. That was good. I didn't include a picture of your tangent like we did for the last one, for sine and cosine. So we don't have that, but I just showed you on Desmos. But let's talk about the general tangent function. So if you have y equals a times tangent of bx. I already told you we don't have an amplitude because now we don't have waves, right? So there's no like height of a wave that we can think about. We do still have a period though. So the period is going to be equal to pi over the absolute value of b. So yesterday it was 2 pi over the absolute value of b. Today it's going to be pi over the absolute value of b. And then really quick, jumping back to this picture, back from chapter 5, remember when we graphed rational functions? What do we have now that we have a tangent? We have a ton of asymptotes. So we have rules for asymptotes. So that basically replaces our amplitude in terms of like things I ask you to find. That's not really accurate, but we have to find our asymptotes now. So the rule for the asymptotes is that they're going to be at x equals pi, and then I'm going to put an n here, pi n over 2 times the absolute value of your b, where n is an odd integer. Because again, you have an infinite number of asymptotes here. So lots and lots of asymptotes. So we're going to put an n in for in general. But your first asymptote would be at pi over 2 times the b. So how we're going to graph these, I need that line there, but we're going to start by graphing key points. So graph key points. I always start by graphing my asymptotes. I do also find my period and label my x and y axes for what I need. I am sure that there is a more mathematical rule for the x-intercepts, but I personally just like to think of the x-intercepts as halfway between asymptotes. Because if you start by graphing your asymptotes, then the x-intercepts are just halfway in between, and you don't have to think about a rule or like, I don't know if you guys realized this yesterday, but like we just didn't use a table to graph sine or cosine, right? Because it doesn't make sense to. So that's why, you know, the asymptotes, or I'm sorry, the x-intercepts, we don't have a table generally, so why find the actual coordinates? That makes sense. Okay, so how does this little a play into it? Because it did change something. So the x values that are halfway between the x-intercepts and asymptotes so the x values that are halfway between the x-intercepts and the asymptotes are either A or negative A. And I'll show you what I mean by that here in a second when we graph our first parent function. So the x values halfway between the x-intercepts and asymptotes are either A or negative A. So these are sort of our rules for graphing tangent. I get to flip? So I want to start by just like yesterday, how we graphed or we looked at like the parent function of sine and the parent function of cosine. We're going to look at the parent function of tangent, meaning where our A is 1 and our B is 1. And I'm going to write down like a list like we did yesterday, but these aren't necessarily going to help you graphing those. Like the key points that we just wrote down are how we're going to graph these really. But let's start with our kind of rules. And so again, I'm going to do in purple, like the rules for this parent function. Then I'll do in pink next to it, like if there's a general rule for it. So for number 1, the period for your parent tangent function is pi. Remember, in general, it's pi over the absolute value of b. Now, yesterday, our domain was all real numbers. Today, your range is going to be all real numbers. So range is all real numbers. And the domain has a bunch of holes in it because we have an asymptote. So I don't know if there's a slick way to write it in, interval notation or our inequality notation, but I'm just going to write it out in plain words. So the domain is all real numbers except pi times n over 2, where n is odd. So in general, it would be that pi n over 2 times your absolute value of b, where n is odd. But again, I don't think I asked you for the domain, and you can see it's just where those asymptotes are. Okay, so your x-intercepts, actually, let's do our asymptotes first. Asymptotes are going to be at x equals, really there should be a plus or minus here, pi n over 2, again, where n is odd. And I should say it's an odd integer, but let's just assume where n is an odd integer. In general, this is going to be at pi times n over 2 times the absolute value of b. So same thing as your domain. But in this picture, you're thinking of just the odd values of pi over 2. So 1 pi over 2. So I have one at 1 pi over 2 here. That means this is undefined. 3 pi over 2 would be the next one. That's undefined. And then the next one would be 5 pi over 2. That's not on our table. But then we also have the negatives. Negative pi over 2 is undefined. Negative 3 pi over 2 is undefined. So I'm going to go ahead and graph those.
What's n?
N is just an odd integer. Remember, there's an infinite number of asymptotes. So you have to plug in different values of n. So different like 1, 2, 3, 4. Except if it's odd, you're just going to plug in 1, 3,
yeah.
and so on. Just because there's an infinite number. So if you just give a rule saying pi over 2, that means there's only one asymptote, which isn't true.
Okay. Thank you.
Let's see here. So got one there. I got one there. Asymptote there. Asymptote there. Okay, so this is definitely more than one period or one cycle. But I've now graphed my asymptotes. The next thing you want to graph, the x-intercepts. These are going to be located, I don't know why I wrote located at pi times n. But in general, just think of them as like halfway. Halfway between asymptotes. I'm running into myself here. Asymptotes. Sorry, I really wanted to squeeze these notes into like 3 pages. So basically your coefficients times pi. So there's one at negative pi. There's one at 0. There's one at pi. And do I have 2 pi on here? Oh, I don't have it on the table, but there's also one here and there. But again, visually, just think about like they're halfway in between. You can see how there's 3 spaces there. I think that makes a lot more sense. And then we actually just graphed it, but your y-intercept is at 0, 0. So it starts like your sine always starts. And today, nothing's going to shift that. Multiplying it by something and changing your period doesn't change that. Okay, the last part of that, which is not in this numbered list for some strange reason. I didn't write this number list. Somebody else did. I just copied it because I thought it was decent. Where those A's come into it. So remember on the other page, we just wrote this thing like with the X values halfway between are either A or negative A. So your A here is 1. So it's going to be at 1 or negative 1. So this, let's say this just counted by 1. So this goes up to 4 down to negative 4. Then that means, and you can think of it, since this is a positive tangent, meaning there's no negative in front of the tangent, it's going to, like, each one is going to look like a positive line. So I'm going to put a point at 1 here and at negative 1 on the left side. Does that make sense? That's the pattern that you're going to see. If this was a 2 in front of this tangent, I would put this point at 2 and at negative 2.
How do you know if it goes this way or that way?
If it's positive versus negative.
Okay.
So this is positive, so it's going to be, and if you think of it like a linear line, like from Algebra 1, they look positive, right? The guy climbing the mountain, Slope Man, or whatever that video is, it's obnoxious. It talks about that. All right, so that's all our points. So if I fill in my table after the fact, because why not? This would be negative 1, 1, negative 1, 1, negative 1, 1. And again, normally we don't have a table. Try and make these curvy, because they're not just straight lines. They look something like that. Okay, and that's a tangent function. Not as much fun to graph as sine and cosine, but still a nice pattern to see if you are a pattern person. Questions about this one? Okay, so let's look at how you're actually going to do this. If you look at example 3, graphing a tangent function, I do like to name my A and B to start. So my A is 2 and my B is 3. And I still like to name my A because while I don't have an amplitude, it does still tell me how to label my x-axis. Oh, or my y-axis. I made a mistake here. I didn't give you guys really enough spaces. I mean, this, you could graph it. It just doesn't look as nice if you want to graph the full period. So we're going to add some lines. So sorry, I didn't do this on your worksheet, but for your notes, this is my second mistake. So just add a line down the middle of each of these boxes. So we're going to graph definitely more than a period here, but that looks better this way. And you can see the pattern better. Ooh, I twitched. Sorry. Okay, that fixes things for us, sort of. Just add a line down each of those middles, and then we have more than enough spaces. But I like to graph a couple of these tangent waves. Okay, so when we're looking at this, the A is going to tell me how far I need to go on my y-axis. So my A is 2, so I'm just going to count by 1, so it'll go up to 3 and down to negative 3. fine. The next thing I'm going to look at for is my period. So the period, it should be where it's pi over your absolute value of b, so it's pi over 3. Now, we still want to split this into 4s, right? So it'd be pi over 12 if you divide it by 4. So each interval is going to be pi over 12. So my period is pi over 3, but my intervals are going to be at pi over 12. Now, again, your worksheet, I did this better. I gave you guys more space. But for this one, I didn't really give you guys enough space. Let me show you what I mean. So like your worksheet, here's the answers for your worksheet. You have enough space to put these. It still kind of runs into stuff. But you do have enough space if you kind of just do it to the side. I really don't have enough space here to make this not look insane. So I'm going to write my x's down below. Sorry, just for space's sake. So this is going to be pi over 3. I'm not pi over 3, pi over 12, excuse me. Pi over 12. This would be 2 pi over 12, which reduces to pi over 6. 3 pi over 12 would reduce to pi over 4. 4 pi over 12 would reduce to pi over 3. So this chunk right here is going to be one whole period. And then it'd be, that'd be 4 pi, 5 pi over 12 would be my next one. And then 6 pi over 12 would reduce to pi over 2. And then just all the negative ones. So this would be negative pi over 2. Negative 5 pi over 12. Negative pi over 3. Negative pi over 4. Negative pi over 6. And negative pi over 12. Are we okay with labeling our x-axes? Was that an okay thing yesterday for us? Well, not particularly pretty, but sorry. All right, so once we have our x-axis labeled, our y-axis labeled, we've got what our period is. I start with the asymptotes. So our asymptotes are going to be at a positive and a negative, and then it would be pi, really times n, I'll just put an n here, over 2 times your b, which is 3. So that means it's going to be at x equals plus or minus pi over 6 would be one. Another one would be plus or minus 3 pi over 6. No, that's not going to reduce. But yeah, that is one, I think, right? 3 pi over 6? Yeah, which reduces to pi over 2. Thank you. Because 3 pi over 6 would be the next one. Fractions, man. So I have one here. Got one here. Got one here. And I got one there. I'm going to clean this out. Okay. Now I'm not even going to write out my x-intercepts because now you can just see them. Like what's halfway between these two asymptotes is going to be this point here. What's halfway between these two is going to be our y-intercept, which is that point there. Halfway between these two, right there. And then the last step is where does your a come into it? So if it's a positive tangent, you go up to 2 on the right, down to negative 2 on the left of each x-intercept. Once you connect these, try and make them curvaceous. It's a little hard when I don't give you as big of a spread on your y-axis, but you can make them look kind of curvy. They're not a straight line is my point. I know we only have 3 points there and it looks like a straight line, but it's not. And that is your tangent function. Just a weird thing to note, and I really didn't point this out to second hour. It's really easy to think of like one period of your sine function should look like that. No, not like that. What am I talking about? Yeah, that's one period, right?
Yeah.
Yeah, that's one period. Ish.
And cosine looks like that is 1 period. Tangent, actually, technically, like what this is saying is that tangent is like, it could be considered this part, right? Because that is officially, so it's like not necessarily one whole wave, but do you see how that's still a period? But I think our eyes often see this as a period, which is correct too. But like, you just have to be careful. Like if I ever ask you for just 1 period, you could give me this, or you could give me this, depending on what you decide to include. Does that kind of make sense? Just a weird thing about these functions. I feel like that's not one thing. I'm missing something for sine there. Yeah, that's extra. Anyways, whatever. Okay, so part B. Just one last example, just so we're super duper clear on this. So start by naming your A and B. So A is 5, B is pi. Since I'm counting by 5, or counting up to 5, I'll count by 2's here. So this can go to 6 and -6. My period is going to be pi over pi, which reduces to 1, which means that I need to count by a 4th. Oops, and I have to add those lines again because I didn't give you guys enough space. Almost forgot. Add them lines. And again, your worksheet is fine. You don't have to do this for your worksheet. I just messed up on the notes. All right, so if I'm counting by a 4th, this would be 1/4. 2/4 is a half. 3/4. 4/4 is 1. 5/4. 6/4 would be 3 over 2. And then the negative side, so -3/2, -5/4, -1, -3/4, -1/2, -1/4. So period, and that A lets us just label our X and Y axes, and then we find our asymptotes. The asymptotes are going to be plus or minus pi over 2 pi in this case, and then again times an n technically. These would cancel out, so we're going to end up having asymptotes at X equals plus or minus, it'll be 1/2 plus or minus 3/2. Somehow that looked wrong for me. There we go. Okay. And then the rest, I think you can just do visually. So our x-intercepts right in the middle. This is a positive tangent. I won't worry about the negatives just yet. So positive tangent, I'm going to go up to 5 on the right, down to 5 on the left. Down to -5, rather, sorry. Up to 5 on the right, down to -5 on the left. 5 on the right, down to -5 on the left. Again, try and make it curvy. It's not just a straight line. Yeah, my first one was better. What do we think of tangent? Questions? Honestly, I think the hardest part about graphing these is probably like labeling the intervals, because we're doing lots of fraction stuff. Because it's, if your n is odd, it'd be 1/2, 3/2, 5/2, 7/2, and so on. So I just went up to 3/2 because that's all I had. All right, if there are no other questions, your worksheet